We've seen that in the Pleistocene period there was great elevation and submergence of land accompanied by violent changes in the climate over the whole surface of the globe. Naturally enough, the severity of the glacial period must have been very intense within the Arctic Circle. We shall be perfectly justified in supposing that the geographical changes, like the elevation and depression of land, occurred on a far more extensive scale in regions round the pole than anywhere else. This leads us to infer that the distribution of land and water about the pole during the interglacial period must have been different from what it is at present. Dr. Warren, in his Paradise Found, quotes a number of authorities to show that within a comparatively recent geological period a wide stretch of Arctic land, of which Novaya Zemlya and Spitsbergen formed a part, had been submerged. And one of the conclusions he draws from these authorities is that the present islands of the Arctic Ocean, such as the two mentioned above, are simply mountaintops still remaining above the surface of the sea, which has come in and covered up the primeval continent to which they belonged. That an extensive circumpolar continent existed in Miocene times seems to have been conceded by geologists, and, though we cannot predicate its existence in its entirety during the Pleistocene period, yet there were good reasons to hold that a different configuration of land and water prevailed about the North Pole during the interglacial period, and that, as observed by Professor Geikie, the Paleolithic man, along with other quaternary animals, ranged freely over the whole of the Arctic regions in those times. Even now there's considerable tract of land to the north of the Arctic Circle, in the Old World, especially in Siberia, where there is evidence to show that it once enjoyed a mild and temperate climate. The depth of the Arctic Ocean north of Siberia is at present less than 100 fathoms, and if great geographical changes took place in the Pleistocene period, it's not unlikely that this tract of land, which is now submerged, may have once been above the level of the sea. In other words, there are sufficient indications of the existence of a continent around the North Pole in the last glacial period. As regards climate, we have seen that during the interglacial period there were cool summers and warm winters even within the Arctic Circle. Sir Robert Ball gives us a good idea of the genial character of this climate by reducing to figures the distribution of heat units over summers and winters. A longer summer with 229 heat units spread over it, and a shorter winter of 136 heat units, which would naturally produce a climate which, according to Herschel, would be an approach to perpetual spring. If the Paleolithic man therefore lived in these regions during the interglacial period, he must have found it very pleasant, in spite of the fact that the sun went below its horizon for a number of days in the year according to the latitude of the place. The present inclement climate of the Arctic regions dates from the post-glacial period, and we must leave it out of consideration in dealing with earlier ages. But supposing that an Arctic continent with an equable and pleasant climate existed during the interglacial period, and that the Paleolithic man ranged freely over it, it does not follow that the ancestors of the ancient race lived in the Arctic regions during those days, though it may render such a hypothesis highly probable. For that purpose, we must either wait until the existence of an ancient race within the Arctic region in interglacial times is proved by new archaeological discoveries, or failing them, try to examine the ancient traditions and beliefs of the race incorporated in such admittedly of the oldest of ancient books such as the Vedas and the Avestas, and see if they justify us in predicating the interglacial existence of the ancient people. It is admitted that many of the present explanations of these traditions and legends are unsatisfactory, and as our knowledge of ancient man is increased or becomes more definite by new discoveries in archaeology, geology, anthropology, or science, these explanations will have to be revised from time to time, and any defects in them, due to our imperfect understanding of the sentiments, the habits, and even the surroundings of the ancient man, be corrected. That human races have preserved their ancient traditions is undoubted, though some or many of them have become distorted in the course of time, and it is for us to see if they do or do not accord with what we know of ancient man from the latest scientific researches. In the case of the Vedic traditions, myths, and beliefs, we have the further advantage that they were collected thousands of years ago and handed down unchanged from that remote time. It is, therefore, not unlikely that we may find traces of the primeval polar home in these oldest books. If the race of ancient man did live in the Arctic Circle in early times, especially, as a portion of the Rig Veda is still admittedly unintelligible on any of the existing methods of interpretation, although the words and expressions are plain and simple in many places. Dr. Warren has quoted some Vedic traditions along with those of other nations in support of his theory that the Arctic regions were the birthplace of the human race. But the attempt, so far as the Vedic texts are concerned, is desultory, as it was bound to be, inasmuch as these Vedic legends and texts have as yet never been examined by any Vedic scholar from a new standpoint, furnished by the latest scientific researches, and as Dr. Warren had to depend entirely on the existing translations. It is proposed, therefore, to examine the Vedas from this new point of view, but before doing so it is necessary to ascertain such peculiar characteristics, or what in logic are called differentia, of the polar or Arctic regions, as are not found elsewhere in the surface of the globe, so that if we meet with them in the Vedic traditions, the polar regions of the latter would be indubitably established. We have seen the inclemency of climate which now characterized the polar regions and was not a feature of the polar climate in early times, and we must therefore turn to astronomy to find out the characteristics required for our purposes. It has been a fashion to speak of the polar regions as characterized by light and darkness 6 months of each, for it is well known that the sun shines at the North Pole continuously for 6 months, then sinks below the horizon, producing a night of 6 months' duration. But a closer examination of the subject will show that the statement is only roughly true, and requires to be modified in several particulars before it can be accepted as scientifically accurate. In the first place, we must distinguish between the pole and the polar regions. The pole is merely a point, and all the inhabitants of the original ancient home, if there was one near the North Pole, could not have lived precisely at this single point. The polar or Arctic regions, on the other hand, mean the tracts of land included between the North Pole and the Arctic Circle. But the duration of the day and night, as well as the seasons, at different places within the Arctic regions, cannot be and are not the same as at the point called the North Pole. Characteristics of the circumpolar region may indeed be derived from strictly polar characteristics, but still they are so unlike each other that it is absolutely necessary to bear this distinction in mind in collecting evidence in the circumpolar original home of ancient times. Men living round the pole, or more accurately speaking in regions between the North Pole and the Arctic Circle, when these regions were habitable, were sure to know of a day and night of 6 months. But living a little southward from the pole, their own calendar must have been different from the strictly polar calendar, and it is therefore necessary to examine the polar and the circumpolar characteristics separately, in order that the distinction be clearly understood. The terrestrial poles are the termini of the axis of the Earth, and we have seen there is evidence to show that this axis has changed position relative to the Earth in the early geological eras. The terrestrial poles and the circumpolar regions are therefore in the same early cases as they are generally near present, though the past and present climatic conditions of these places may be totally different. But the axis of the Earth has a small motion round the pole of the ecliptic, giving rise to what is known as precession of the equinoxes, and causing a change only in the celestial and not terrestrial poles. Thus, the polar star of 7,000 years ago was different from what it is at present, but the terrestrial pole remains generally the same. The motion of the Earth's axis producing the precession of the equinoxes is important from an ancient point of view, inasmuch as it causes the change in the times when different seasons of the year begin. And it was mainly by utilizing this as a chronometer that you could show that the vernal equinox was in Orion and some of the Rig Vedic traditions were formed, and that the Vedic literature contained enough early evidence of the successive changes of position of the vernal equinox up to the present time. Thus the vernal equinox was in Kritias at the time of the Taittiriya Samyata and the Brahma, and the express text stating that the Kritias never swerve from the due east. All other nakshastras do. Published by late Mr. S. B. Dixit, serves to remove whatever doubts there might have been regarding the interpretation of the other passages. This record of the early position of the Kritias, or the Pleiades, is important in the determination of the Vedic chronology, as the orientation of the pyramids or temples has been in the case of the Egyptians, as shown in books such as The Dawn of Ancient Astronomy. But the chronometer, which I now mean to employ, is a different one. The North Pole and Arctic regions possess certain astronomical characteristics which are peculiar to them, and if a reference to these can be discovered in the Vedas, it follows, in the light of modern researches, that the ancestors of the Vedic rishis must have become acquainted with these characteristics when they lived in those regions, which was possible only during interglacial times. We shall therefore now examine these characteristics, dividing them in the twofold way stated above. If an observer is stationed at the North Pole, the first thing that will strike him is the motion of the celestial sphere above his head. Living in the temperate and tropic zones, we see all heavenly objects rise in the east and set in the west, some passing over our heads, others traveling obliquely. But to the man at the pole, the heavenly dome would seem to revolve around him from left to right, somewhat like the motion of a hat or umbrella turned over one's head. The stars will not rise and set, but will move round and round in horizontal planes, turning like a potter's wheel, starting on a second round when the first is finished, and so on during the long night of 6 months. The sun, when he is above the horizon for 6 months, would also appear to revolve in the same way. The center of the celestial dome over the head of the observer will be the celestial North Pole, and naturally enough his north will be overhead, while the invisible regions below the horizon would all be south. As regards the eastern and western points of the compass, the daily rotation of the earth round its axis will make them revolve round the observer from right to left, thereby causing the celestial objects in the east to daily revolve round and round along the horizon from left to right, and not rise in the east, passing overhead and set every day in the west as it is with us in the temperate or tropical zones. In fact, to an observer stationed at the North Pole, the northern celestial hemisphere will alone be visible, spinning round and round over his head, and the southern half, with all the stars in it, will always remain invisible, while the celestial equator, dividing the two, will be his celestial horizon. To such a man, the sun, going to the northern hemisphere in its annual course, will appear as becoming from the south, and will express the idea by saying that the sun has risen in the south, howsoever strange that expression may seem to us. After the sun has risen this way in the south, and the sun will rise there only once a year, he will be constantly visible for 6 months, during the time which it will attain a height of about 23.5 degrees above the horizon, and then begin to lower down until it drops into the south below the horizon. It will be a long and continuous sunshine of 6 months, but as the celestial dome over the head of the observer will complete one revolution in 24 hours, the sun will also make one horizontal circuit round the observer in every 24 hours, and to the observer at the North Pole, the completion of one such circuit, whether of the sun or of the stars, will serve as a measure of ordinary days, or periods of 24 hours during the long sunshine or night of 6 months. When about 180 such rounds, the exact number will depend on the difference in the durations of summer and winter noticed in the last chapter, are completed, the sun will again go down below the horizon, and the stars in the northern hemisphere, which had disappeared in his light, will become visible all at once, and not rise one after the other as with us. The light of the sun had, so to say, eclipsed them, though they were over the head of the observer, but as soon as the obstruction is removed, the whole northern starry hemisphere will again appear to spin round and round the observer for the remaining period of 6 months. The horizontal motion of the celestial sphere, only one long continuous morning and evening in the year, and one day and one night of 6 months each, are thus chief special features of the calendar at the North Pole. As we have stated that to an observer at the North Pole there will be a night of 6 months, one is likely to infer therefrom that there will be total darkness at the pole for 1/2 the portion of the year. Indeed, one is likely to contemplate the horror, the perils and difficulties of a long night of 6 months, during which not only the light but the warmth of the sun has to be artificially supplied. As a matter of fact, such a supposition is found to be erroneous. First of all, there will be electric discharges, known as the Aurora Borealis, filling the polar night with their charming glories, and relieving its darkness to a great extent. Then we have the moon, which in her monthly revolution will be above the polar horizon for a continuous fortnight, displaying her changing phases without intermission to the polar observer. But the chief cause which alleviates the darkness of the polar night is the twilight before the rising and after the setting of the sun. With us, in the tropical or temperate zone, this twilight, whether of morning or evening, lasts only about an hour or two, but at the pole, this state of things is completely altered, and the twilight of the annual morning and evening is each visible for several days. The exact duration of this morning and evening twilight is, however, still a matter of uncertainty. Some authorities will fix the period at 45 days, while others make it last a full 2 months. In the tropical zone, we see the first beams of dawn when the sun is about 16 degrees below the horizon. But it is said that in higher latitudes the light of the sun is discernible when it is from 18 to 20 degrees below the horizon. Probably this latter limit may prove to be the correct one for the North Pole, and in that case, the dawn there will last continuously for 2 months. Captain Pym, quoted by Dr. Warren, thus describes the polar year. On the 16th of March, the sun rises, preceded by a long dawn of 47 days, namely, from the 29th of January, when the first glimmer of light appears. On the 25th of September, the sun sets, and after a twilight of about 48 days, namely the 13th of November, darkness reigns supreme so far as the sun is concerned, for 76 days, followed by one long period of light, the sun remaining above the horizon 194 days. The year, therefore, is thus divided at the pole: 194 days of sun, 76 darkness, 47 days dawn, and 48 of twilight. But other authorities assign a longer duration to the morning and evening twilight and reduce the period of total darkness from 76 to 60 days, or only about 2 months. Which of these calculations is correct could be settled only by accurate observation of the North Pole. It has been ascertained during this duration it does depend on the powers of refraction and reflection of the atmosphere, and these are found to vary according to the temperature and other circumstances at the place. The polar climate is at present extremely cold, but in the interglacial epoch it was different, and this by itself would alter the duration of the polar dawn in interglacial times. But whatever the case may be, so much is beyond doubt that at the pole the twilight of the yearly morning and evening lingers on for several days. For even taking the lowest limit of 16 degrees, the sun in its course of the ecliptic would take more than a month to reach the horizon from this point, and during all this time a perpetual twilight will prevail at the pole. Long dawn and short evening twilight are therefore principal factors in the shortening the darkness of the polar night, and if we deduct these days from the duration of the night, the period of darkness is reduced from 6 to 2, or at most 2.5 months. It is therefore erroneous to suppose that a half-yearly polar night is such a continuous period of darkness as will make the polar regions uncomfortable. On the contrary, it will be the peculiar privilege of the polar man to witness the splendid spectacle of a long continuous dawn with its charming lights revolving like the stars at the place every day in the horizontal planes round and round him as long as the dawn may last. The dawn in tropical and temperate zone is but brief and effervescent, and it recurs after every 24 hours, but still it has formed the subject of poetical descriptions in different countries. If so, how much more the spectacle of a splendid long dawn after a darkness of 2 months would delight the heart of a polar observer, and how he will yearn for the first appearance of the light in the horizon could be imagined better than described. I quote the following description of this long polar dawn from Dr. Warren's Paradise Found, and invite special attention to it, inasmuch as it forms one of the principal characteristics of the North Pole. The premise that the splendors of the polar dawn are indescribable, Dr. Warren proceeds. First of all, appears low on the horizon of the night sky a scarcely visible flush of light. At first, it only makes a few stars' light seem a trifle fainter, but after a little it is seen to be increasing and to be moving laterally along the yet dark horizon. 24 hours later, it has made a complete circuit around the observer and is causing a larger number of stars to then fade. Soon the widening light glows with the luster of an orient pearl. Onward it moves in its stately rounds until the pearly whiteness burns into a ruddy rose light, fringed by purple and gold. Day after day, as we measure days, the splendid panorama circles on, and according as atmospheric conditions and clouds present more and less favorable conditions of reflection, it kindles and fades, and fades only to kindle next time yet more brightly, as the still hidden sun comes nearer and nearer his point of emergence. At length, when 2 long months of such prophetic displays have been filling the whole heavens with these incessant and revolving splendors, the sun begins to emerge from his long retirement, and to display itself once more to human vision. After 1 or 2 circuits during which the dazzling upper limb grows to be a full-orbed disk, it clears all hilltops of the distant horizon and for a full 6 months circles round and round the world's great axis in full view, suffering no night to fall upon its favored homeland at the pole. Even when at last it sinks again from view, he covers his retreat with a repetition of the deepening and fading splendors which filled his long dawning, as if at these pulses of more and more distant light he were signaling back to the forsaken world the promise and prophecies of an early return. A phenomenon like this cannot fail to be permanently impressed on the memory of a polar observer, and it will be found later on that the oldest traditions of the ancient race have preserved the recollection of this period, when its ancestors witnessed such wonderful phenomenon, a long and continuous dawn of several days with the lights laterally revolving in the horizon in their original home. Such are the distinguishing characteristics of the North Pole, that is, the point where the axis of the Earth terminates in the north, but the polar home means practically a home in the regions round about the North Pole and not merely at the polar point. We must now see what modifications are necessary to be made in the above characteristics, owing to the observer being stationed a little to the south of the North Pole. We have seen that the northern hemisphere can be seen spinning round the observer, and all the stars move with it in horizontal planes, without rising or setting, while the other celestial hemisphere is always invisible. But when the observer is shifted downwards, his zenith will no longer correspond with the pole star, nor his horizon with the celestial equator. For instance, let Z in the shown figure be the zenith of the observer and P the celestial North Pole. We can see when the observer is stationed at the terrestrial North Pole, his zenith coincided with P, his horizon with the celestial equator, with the result that all the stars in the dome, designated Q' PQ, revolved around him in horizontal planes, but when the zenith is shifted to the location of Z, this state of things is at once altered, as the heavens will revolve, as before, round the line of PO, P', and not around the zenith line of ZO, Z'. When the observer is stationed at the North Pole, these 2 lines coincide, and hence the circles of revolution described by the stars round the celestial pole were also described round the zenith line, but when that zenith line is different from the polar line, as in the figure, the celestial horizon of the observer will be H', and the stars will now appear to move in circles inclined to his horizon, as shown in the figure by the black lines of A', B, R prime, and C, C prime. Some of the stars, such as those that are situated in a part of the celestial dome represented by H prime, P, B, will be visible throughout the night as their circles of revolution will be above the horizon of B prime, C prime, D prime, H. But all the stars whose polar distance is greater than PB or PH will in their daily revolution be partly above and partly below the horizon. For instance, the stars at C and D will describe circles, some portions of which will be below the horizon of H prime H. In other words, the appearance of the visible celestial hemisphere to a person whose zenith is at Z will be different from the appearance presented by the heavens to an observer at the North Pole. The stars will now not revolve in horizontal planes, but obliquely. A great number of them would be circumpolar and visible during the whole night, but the remaining will rise and set, as with us in the tropics, moving in oblique circles. When the zenith is very near the polar line, only a few stars will rise and set in this way, and the difference will not be a marked one. But as the zenith is removed farther south, the change will become more and more apparent. Similar modifications will be introduced in the duration of day and night when the observer's position is shifted to the south of the terrestrial North Pole. This will be clear by the reference to the figure included. Here let P be the celestial North Pole and Q prime Q the celestial equator. Since the Sun moves in an ecliptic, E prime E, which is inclined at an angle of about 23.5 degrees, 23 degrees 28 minutes, to the equator, the circles of T prime E and E prime T will correspond with the terrestrial circles of the latitude called the tropics, and the circle AC to the Arctic Circle on the terrestrial globe. Now, as the Sun moves in the ecliptic of E prime E, its annual course will always be twice overhead for the observer stationed at a place within the terrestrial's tropical zone, once in its course from E prime to E, and again in its return from E to E prime. The Sun will also appear for some time in the north of the observer's zenith, and for the rest of the year to the south. But as the altitude of the Sun above the equator is never greater than 23.5 degrees, or EQ, an observer whose zenith lies to the north of the circle T prime E will always see the Sun to the south of his zenith, and the zenith distance of the Sun will be greater and greater as the observer advances towards the North Pole. But still the Sun will be above the horizon every day, for some hours at least, and to an observer whose zenith lies between T prime E and AC. To take a concrete instance, let the observer be so stationed that his zenith will be at C, that is, on the extreme northern latitude of the temperate zone. Then his celestial horizon will extend 90 degrees on each side and would be represented by T prime C T. And the Sun, moving along the ecliptic E prime E, will be above his horizon at least some portion of the day during the whole of the year. But as an observer passes into the frigid zone, the Sun, during its annual course, will be altogether below the horizon for some days, and the maximum limit is reached at the northern pole, where the Sun is below the horizon for 6 months. We may therefore state that the duration of the night, which is 6 months at the pole, is gradually diminished as we come down from the pole until in the temperate zone the Sun is above the horizon at least for some time out of 24 hours every day. In the foregoing figure, letting Z represent the zenith of the observer within the Arctic regions, and H prime H representing its horizon, and the Sun in its annual course will for some time be altogether below the horizon. For instance, suppose the Sun to be at small n, when its diurnal circle of rotation will be represented as small n H, the whole of which is below the horizon of H prime H, the observer's zenith is Z. Therefore the Sun, during its annual course along the ecliptic from E prime to N and back from N to E prime, will be invisible to an observer whose zenith is Z. Corresponding to this total disappearance of the Sun for some time, the luminary will be perpetually above the horizon for the same period during its northern course. For instance, let the Sun be at small d, then his diurnal circle of rotation, small d H prime, will be entirely above the horizon of H prime H, and so it will continue to be for all the time that the Sun moves from D to E and back again from E to D in its annual course. During this time, the sun will neither rise nor set, but will move like the circumpolar stars in oblique circles, round and round the observer like a wheel. For all positions between little n and little d, the corresponding portion of the ecliptic and the other side of the sun, in its diurnal course of 24 hours, would be partially above and partially below the horizon, producing ordinary days and nights, as with us, the day being longer than the night when the sun is in the northern, and the night longer than the day when the sun is in the southern hemisphere. Instead of a single day and single night of 6 months, a year to a person living in the Arctic regions, but not exactly at the North Pole, is therefore divided into 3 parts, one of which will be long night, one long day, and one made up of a succession of days and nights, a single day and night of which will together never exceed 24 hours. The long night will always be shorter than 6 months and longer than 24 hours. The same will be the case of the long day. The long night and long day will mark the 2 opposite extremities of the year, in the middle of the long day occurring when the sun is at the summer solstice, and the middle of the long night when it is at winter solstice. This triple division of the year is very important for our purpose, and it shall therefore illustrate with a concrete example. Suppose, for instance, the observer is so far below the North Pole that instead of a night of 6 months, he has a night of 2 months, or, in other words, the sun goes below his horizon only 2 months. As the winter solstice will fall in the middle of this long continuous night, we may say the night will extend a month before and after December 21st, when the sun is at the winter solstice. Corresponding to this long night, there will be a continuous day of 2 months, a month before and a month after June 21st, when the sun is at the summer solstice. If these 4 months are deducted from the year, there will remain 8 months. During all these months, there will be days and nights as in the temperate zone, a day and night together never exceeding, as with us, the ordinary period of 24 hours. This alternation of ordinary days and nights will commence after close of the long night in January, and in the beginning, the night will be longer than the day, but as the sun passes from the southern to the northern hemisphere, the day again gains over the night, and eventually, after 4 months, terminate into continuous day of 2 months. At the close of this long day in July, the alternation of ordinary days and nights will again commence, the day being longer than the night, but together never exceeding, as the previous case, a period of 24 hours. As the sun passes from the northern into the southern hemisphere, the night will begin to gain over the day until, after 4 months of such succession of ordinary days and nights, it terminates into a continuous night of 2 months mentioned above. The same description applies where the long night may last for 3, 4, or 5 months until we reach the polar condition of a day and night of 6 months each, after which the immediate succession of ordinary days and nights vanishes. We have seen that the long dawn of 2 months is a special important characteristic of the North Pole. As we descend southward, the splendor and duration of the dawn is witnessed on a less and less magnificent scale, but the dawn, according to the end of the long night of 2, 3, or more months, will still be unusually long, often several days' duration. As stated above, at first only a pale flush of light appears, and will then continue visible on the horizon, revolving round and round. If the observer is sufficiently near the pole for some days, when the last orb of the sun will emerge and start for the alternation of day and night as described above, to be eventually terminated in a long day. The splendors of the Aurora Borealis would also be less marked and conspicuous in the southern latitudes than in the North Pole. But if the characteristics of the Arctic region are different from those of the North Pole, they are no less different from the features of the year which we are familiar with in the temperate or tropical zone. With us, the sun is above the horizon at least for some time every day during all the 12 months of the year, but to persons within the Arctic Circle, it is below the horizon and therefore continuously invisible for a number of days. If this period of continuous night be excluded from our reckoning, we might say that within the Arctic regions of the year, or the period marked by sunshine, only lasts from 6 to 11 months. Again, the dawn in the temperate and tropical zones is necessarily short-lived, for a day and night together cannot exceed 24 hours, and the dawn which comes between them can only last a few hours. But the annual dawn at the pole and the dawn at the end of the long night of the Arctic regions will each be a dawn of several days' duration, As for the seasons, we have our winters and our summers, but the winter in the Arctic regions is marked by a long continuous night, while the summer will make the night longer than the day, but within the limit of 24 hours until the day is developed into a long continuous sunshine of several days. The climate of the polar regions is now extremely cold and severe, but as previously stated, different climatic conditions prevailed in early times, and we cannot, therefore, include climate amongst the points of contrast under consideration. It will be seen from the foregoing discussion that we have two distinct sets of characteristics or differentia, one for an observer stationed exactly at the terrestrial pole, and the other for an observer located at the circumpolar regions or tracts of land between the North Pole and the Arctic Circle. For brevity's sake, we shall designate these two sets of differentiae as the polar and circumpolar and sum them up in the next video. Thank you.